So this is the spirograph. So we want to plot an interesting picture using the cosine and sine functions as a function of time. So I'm going to do this in a new window, a new script file, sorry, just so that we can save it and play around with it later. So first of all, we need to start with a time vector. So exactly as before, time is equal to the start value, some step size, which I'm going to make 0.01 times by pi. Again, if we do a constant times by pi, we get exact numbers at the end. That's not very described very well. We would go exactly to 12 times pi, which is our end value. So we can run this. Well, we need to save this first, so I'm going to save this as spirograph. And we can click run, and we can see in the Matlab command window we have time being all of these values. So that's quite a lot, and we obviously don't want to see that every time we run it, so a semicolon at the end of the line. Now, because we're going to plot lots and lots of points, we need to do one helper function. We need to type hold on, and this just tells Matlab when we plot a point, keep that Matlab figure open because we're going to plot more points to it. And now we need to iterate over time. So we're going to have this for loop as before. So for, and let's have a variable k equals to 1 times by the length of time. So the length of time tells us how many different numbers are in that time vector that we generated up here. And we're going to have k being each one of those in turn. And that has an end at the end of it. So everything we write inside this for loop is going to happen k times. So now we know our time vector, and we know an index along the time vector. So at each time point we have time k giving us the current time. So we could include this in all of our sine terms, except the easier thing to do would be to call a new variable equal to this command. So now at each time this for loop is run, k times again, we update t to be equal to the time at that point. Now we want to make an x and a y that are some fun values of our cosine and sine vectors as a function of our time. So I'm just going to pick something at random. So 11 times the cosine of t. Remember, that's our time. I'm very sorry, I need to do x equals 11 times the cosine of t. Say minus 6 times sine, 22 times t over 6. So these numbers that I'm timesing both t, dividing t, and multiplying the cosine and sine variables by are completely arbitrary, and they're up to me to decide. And varying them will give us different graphs in a bit, so you might have to try different things that will give you different interesting results. Okay, now y we need to pick again, so I'm going to go with relatively similar to before, 11 times sine times t minus 6 times cosine times 11 times t divided by 7. So again, that's just my choice. And now I need to plot each of these points. So again, we call the plot command, we say x, we say y, and now if we normally call the plot command multiple times, we'll end up having loads and loads of colours and loads, and we won't have the right symbols. So what we need to do is tell Mathematica that we want, and this is now in quote marks, that we want circles, and we want them to be black, and the command for black is k. So although it looks like I'm writing OK, actually I'm telling Matlab I want circles and I want them to be black. Okay, so now we can try running this script. So I'm going to save it, and then I'm going to run. And this should open a figure file with our interesting result. So here we go. So if I make them a bit bigger, you should be able to see how my spirograph was plotted. I would note here that I've forgotten to write a semicolon at the end of the X and the Y line, which I'll do so now. And what that's meant is I've got all of these values within the Matlab command window, which isn't great. So let's clear that, do the semicolons, and then run that again. And that should be hidden behind in our figure 2. And I'm going to pass back to Gerald.
Okay, so I'll close this window, and as our final point for today, what we are going to do is close this window down, and I clear this window. I have 2 comments on it. So one thing is that, of course, rather than just having a plot on the screen, you might also want to save it. So for those who don't know, it is under File in the top panel. Under File, you can see the possibility to save as. So a plot can be saved as. If you click on this, it will give you the possibility to select from a variety of formats. And specifically all the picture formats, JPEG, EPS, TIFF, and so on are there. So I might, for example, use the portable network graphics format. And this is a way to save your plot, say Spirograph 1, or it's my Spirograph, and it will, in this case, save it to the desktop. If that's done correctly, then it should be now on my desktop, as indeed it is. And you can see this is how Matlab saved the figure on the desktop. So you have a save possibility there. For the spirograph, we have thought to make a bit of a contest. So we ask everybody to be creative and try to produce some interesting graphs and nice and colored graphs. And I have given you a couple of tips to how to potentially do this in the accompanying file, where it tells you how you can not only produce a graph, but how you can also change the graph. So specifically, if you look into the command, there's a way of setting the plot background. I don't go into the details here, but if I execute this code, which you should also do, to get a white figure, you can use certain commands with specifying the color, and you can have a different background for the axis if you wish to do so by doing the set command. So we don't go into detail explaining all of this, but we recommend that you use those pieces of code in the file to experiment on them, because this is mostly how a lot of your Matlab work is going to be in the future, that you have to pick a new function and try to modify it such that it does what you want to do it. In the file, you have also comments that help you working with all these commands, and also gives you some hint at where you find further help. And as a final comment, and I'm not going to explain this in detail, I'm just showing you this last set of code here, which you can try and look at it if you like. Helps you to do a fancy graph, namely to use the commands that I explained above to make a black background and to plot your figure in red on top of it, and have a very funny feature that one of the students of the previous cohorts actually invented, namely to not only give one color to the graph, but actually change the color of the point plotted in the graph every time the function is evaluated. So without explaining, I just execute this command and we'll see the result. And you can see from this here, you can get a black figure with a colored background, and the plot, rather than being uni-colored, has actually the colors of the rainbow as you go through the spirograph. It takes a little bit of MATLAB knowledge to understand what is going on, but I encourage you to experiment with these things and to upload the nicest graph that you get. We are going to have a contest which is going to be announced by the administration next week, and I think an Amazon voucher and potentially a SysMIC t-shirt with your graph plotted onto it are the possibilities that we are discussing. We'll have that published later on, and you'll get an idea of how this is done by a message from the administrator. I conclude today's session by showing you a feature which is immediately done. If you look at this command, if you have done a time command called t here, time points, and you have x and y variables, you have actually three arrays, t, x, and y. MATLAB is also able to produce pseudo 3D graphs that plot t against x against y in one coordinate system, so 3D graphs. For those who want, I'll just show you quickly how to do this. Rather than plotting x and y, you can expand this by adding t. So then you say MATLAB is supposed to plot t and x and y in one plot, but the function to do so is no longer called plot, it's a variant, it's called plot3. So if you do this command plot3 on t and x and y, similar to like we have done before, then in this current somewhat advanced graph, what you get is a plot that looks slightly irritating at the beginning, but we understand immediately what it means if you use the rotation option to rotate this coordinate system around. And I make it bigger so you can see that better. You can see that by using 3D rotation, you can use this 3D coordinate system around and produce whatever plot you want to be.